Hello, everyone. So today what we'll be talking about is the Assignment 3 lab tasks. Last lecture went over the written materials and a couple of common things to watch out for while you're working through those. So we'll be taking a look at the rubric. And in here, once again, just like Assignment 2, you're going to have the 60% of just following along with the documents, making sure everything is working from those. The big ones to watch out for this one, obviously reticle changing color. We have it so the projectile is actually aiming towards the reticle. Then down here, it's talking about the animation stuff that we've added. So making sure that that hurt animation plays when they take damage, jump, double jump, making sure all those animations are nice and smooth and there aren't any stutters between those. Along with the target being added. And last thing down here is to make sure that you did add the main menu level and you can transition from that main menu to the level itself. One thing I didn't mention about the main menu from last lecture, let's actually take a look at that. When you just play from the normal level, it should not load up that main menu widget. So it's very important that when you are telling it to load the widget in the level blueprint, that you actually have the main menu level loaded and only add it to this level blueprint and not the level blueprint from our level 1. Otherwise, you're just creating a widget inside our gameplay level, which we should have a totally separate level since our main menu shouldn't have any characters or anything like that running in the background when it's just in a menu. So that's just something to watch out for real quick. I don't want to close this. Talking about the lab tasks. So we'll take a look at those lab tasks now. And so this first one's asking you to use to use interface communication like we were showing in our very first part of this assignment. And they want to use that for the pickups. So right now our pickups are using that direct communication where they're casting to the player, then calling a function from it. However, since our character should be using an interface and things really shouldn't be referencing each other that much, it just creates unneeded references. Rather than having our pickups directly reference, so for example, our ammo pickup is casting to our character, we could move this add to max ammo function over to our interfaces. We already have an interface for our character set up. So rather than creating a brand new interface and having to add it to the implemented stuff, we can just add that function. And once we add it here, we can then go to our base character and just do the replacing portion where instead of having all that functionality right here, we can add it to an interface function or even event as needed. So moving on from that one, this one's asking for the characters to be different colors. So we've taken a look at how we can set a vector parameter for a reticle on this assignment to change the color of something in game at runtime. This one's asking you to do it for our character colors. Now it's not asking for an entire new material or anything. The material that it actually has already, if we take a look at that, our mesh is the one that has the rendering stuff. So our M_UE4 man body is the material it's using. For quick reference, I can click this little magnifying glass and it pulls it up in the content browser. I'll just hide those. There we go. We can open this up and scroll out. And this is obviously a lot more complicated than the materials we've been using so far. The big thing I want to point out is that you don't have to modify this material. It's already got a parameter on it named body color. If we wanted to modify that inside our base character, let's say we wanted it anytime it lands to change color. We would want to get that material from our mesh. So we can drag our mesh component in here, get that mesh component, then we can ask set vector parameter. And this functions just like the parameter one that we have set up for changing the HUD. We need to tell it which name of the parameter we want to change. And this one was called body color. We can then tell it what color we want, even create a variable just like we did for our HUD. And we could check this out. Obviously, you wouldn't want to do it on here if we want our enemy and our player to be different colors, but this is just showing which function to call, not where to put it exactly. If we play this, so character starts off just normal color. We actually run up and trigger that on landed, we see it change that character's color. So a couple of things about this. If we want our characters to be different colors, well, right now they're both base characters. I would need some sort of branch, and what I would branch on is if they're player controlled or not. And so characters actually have this really useful function for doing that called is player controlled. And that returns you a bool, which can easily be branched from, on whether it is player controlled or not player controlled, allowing you to take one route to actually set the color to green or whatever you want your enemy's color to be, and then one route for whatever your player wants to be. So that's just a couple of ways to get started on that one. This task is asking that they are different colors and that they do start the game out as different colors. So keep that in mind. A good place to put something that we need to have run when the game first starts is probably a begin play. That should get you started on that one. This one is asking you to create a new pickup. This pickup is going to be more advanced than our other pickups. What this one should be doing is adjusting our speed, going up by 100%, so doubling whatever our current speed is. And it's also got a timed element to it. So it should only last for 5 seconds. Satisfactory is going to be if there's timing incorrect, if it's hard coded to only work with one speed. So we haven't talked too much about how our character moves or what speeds it's at or anything like that. So what we'll take a look at is our character movement. I'm going to just move that out of the way. And down here, our walking. Our max walk speed is what our character's default movement will be. So that's currently just 600. I'd want this pickup to work if we had our character start out at like 100, and then it should just be doubling this number. So just like we were getting our material from our mesh, in order to access this, we need to get our character movement component. And then we have the ability to set max walk speed or get our max walk speed. And we'd have to do some math to make sure to just double whatever its current value is. And then we need the delay portion. So I believe we mentioned it a little bit about delays before and stuff, but let's take a look at an example of this. We could even take a look at if I wanted to delay this from happening. There's something really useful inside our event graphs. We have what is called a delay node. The delay node, when our input action is pressed, it'll run up to here and it'll actually pause for this amount of duration before it starts running anything connected on the right. So if we wanted to delay our jump, let's say we want a 2-second delay before it actually jumps. And I'm going to just break the link to stop just real quick for this example. And if we play, so I'm going to bring my mic close to my keyboard, and I just press space, and it waited for 2 seconds before it actually jumped. All right, so that's really useful, but if we wanted to use this inside a function, say for example in how our pickups are set up in general, we have this function called add to max ammo. This is the one that we're calling from our pickup. If we try and add delay here, we see not a whole lot comes up, or a lot of just kind of gibberish stuff comes up. You can't do delays inside functions. So one thing I could do is change this to actually just be an event and have that very easy interface over in the event graph. Or if we're inside a function and still want something to run after something else, we can use another thing called set timer. And there's a couple options: set timer by event or set timer by function name. Personally, I like the set timer by function name. And you can just type in which function you want to call, how much time to delay before it calls it. And you could set up another one, like for example, if we set up a pickup to increase our speed and it just calls this increase speed, we could have it set the new speed and then call another function that resets the speed after a certain amount of time. So just to show how this would work, let's say this is going to increase our ammo, but then after it does it, we'll have it call another function using that timer. And we'll say function name, print message. Got to make sure that it has a time. This set timer by function name will not work if it's set, the time is set to 0. So let's say it's going to delay for 3 seconds. And then we got to create a function named this exact thing. So watch out for any trailing or leading spaces. So print message, capital P, capital M. We'll go ahead and create one. And we'll call it print message. We can have this just simply do a print. Timer was up. This is where you'd reset. Compile, save. If we take a look at how this is working without having to do anything in the pickup, because remember the pickup just calls that character's function. If we let that get out of the way and we run into the pickup, 1, 2, 3, we get that print message up in the top corner. Once again, if you do ever miss any of the screen messages or weren't looking for it, you can always check out your output log. We see that base character printed a message that the timer was up, and that's how you could set up something on a time delay. All right. Back over to the rubric. This one's asking you to add some visual effects to the game. This one's specifically talking about when a target gets destroyed, a particle system should spawn in its place. So explosion happens, it's about the same size as that target object. So that size requirement is just making sure that you don't have one of those little targets in the level. And I'm going to just open up the main level so I don't have to keep opening or keep pressing play. If we have a target that's only this big and we had an effect that's blowing up and taking up half of the level size, Obviously, that's not very well balanced. So don't worry about getting the scale perfect. Just make sure it's going to explode about that size. As far as how to spawn an effect, well, there's a very useful function. We just go into any blueprint called spawn emitter at location. In here, this is very similar to the spawn actor of class. You can select different particle effects. We have one created for you called P_explosion. You got to give it a location. And this part right here, you want to make sure that it is at whatever actor you just destroyed's location. So for example, once again, just making sure that it lines up with the end game. So if I explode this one over here, I don't want to see an explosion over here at like origin or something. It should happen right at that same location that that actor that got destroyed was. That's about it for that one. So just making sure that it's not in the wrong location, or it's not just looping an explosion or things like that. It should only happen when the target itself gets destroyed. Here, this is going to be one of the research tasks. So this one's asking you to create a fade in and a fade out. So what should happen is when you're in the main menu, you press play, it should fade out to black, and then after about a second, the game should start fading in so you can load up the level. Let's take a look at that. Over here I have all the labs implemented here. If we start from main menu, press play, if I click this play button, we'll see it actually fade to black, and then the game gets loaded and it fades in from black. So there is a YouTube link here that goes over several different examples of fading in and out. One big thing to watch out for is that fading a widget like the main menu cannot be done in a lot of the ways that are shown, only the UMG way, which is at the very end of how that works. So things like the level and are going to need a different technique other than, well, things like the main menu and the HUD will need a different technique, a very specific technique that we could take a look at. Let's say, let's actually just go to our, now I'll do it in the main menu. So our main menu. In widgets, they're referred to often as something called UMG, which stands for Unreal Motion Graphics. And that actually means that each one of the widgets themselves has an animation associated with it and a timeline and stuff. The very first thing that they go over is, I believe, level sequences. Widgets cannot be faded using a level sequence. They can, just in a very roundabout way and not as simple as like doing a fade in sequence or something. But you can add animation tracks. Let's just call this, I'm not going to show you how to do the fade. That part you'll have to watch the video for, but for example, if I want this one to, let's have our play button move up on the screen when I press play, just to show you how to get an animation playing. We'll call this animation track move up. You can then select it. Move that out of the way. We then add a specific track for this animation. And over here, we have to select which widget we want this animation affecting. Well, we can select all the individual components, or if we select that'll be the entire widget itself. For this one, we did just say we want the play, let's do the entire, not too sure which one I want. That's a tough call. let's go for this. We'll make the entire widget fit move up for this. We can then add a specific track for this widget, and we have a lot of different options for if we wanted to change its color and opacity or fade it out or something. We could use that track. If we wanted to change the color, going to black would also be another way of doing that one. Render opacity is another way to fade. But we want to modify this one's position, so we'll be looking at transform. So transform, you have translate, rotate, scale. And what happens is over here, using this timeline, we can actually add different keyframes to this. So let's say after 2 seconds, we're going to add a key for this translation. And we want this moving up. So this is in pixels. We'll move it way up there when it's at this key. So as we watch our animation, we see it's now moving that up. We could even just play this animation and test it out. We see it's going to scroll up after we press play. Now, one thing we want to do is tell this animation to play in code. So we want this to happen. I'm going to scrub this back to 0 so we can actually see this. We want this to happen when we're clicking on this play button. We already have that event overloaded so that it's telling it to load the level. On clicked for the play button, if I want to get our animation, well, since we added it through the designer, it automatically adds this animations under variables for you, and will let you know whatever you name that animation. We can get that and tell it to play. So when we press play, it's going to tell the animation to play. If we watch this from in-game and try and test this out, if we click play, we see it didn't really play that move up animation. So the problem is, right here, right after we tell that animation to play, so the animation's on its very first frame, we're immediately telling it to load next level. Well, load next level unloads everything in the current level. If we actually watch our outliner, what's going on when we press play, we see it did add all of this stuff, including the widget for the screen. As soon as we press play, it unloaded everything from the previous level and now loads everything for this level. So we never gave it time to actually play the animation. Well, here's where that delay can come in handy again. So before we tell it to do the cast and loading the next level, we can simply delay, and we could tell it how long to delay using a hard-coded value, or we could even ask our move up animation what its end time is. So now if I change how long that animation is supposed to last or the number of keys in the designer, it'll always make sure to delay for whatever amount of time that I want. So we press play, we see that scroll up off screen, and our game loads. So that should get you started on how you could set up a simple animation. Fade it, I'll let you watch the video for how to fade in a level or something like that. And one other thing that you'll also want to make sure is for full credit, it also has to fade in the HUD. So remember, your HUD is a widget, but that's in the game scene itself. So you will want to use a widget animation for the HUD as well. Next up, we have another research assignment. So this one's asking for a pop-up widget over important game elements in screen space. There is a link to the forums here. If we pull that up, we can take a look at it real quick. And there is warnings and stuff saying it's out of date. You're more than happy to research the other ways to do it, but I am letting you know that this method will work fine to get it on screen. There's a couple of issues with it that are answered later in the forum that you'd have to dig through to try and figure out a couple of issues. So it describes how to set up some basic text. Here's an example of what it would look like. Great example of how we could use this is for our different pickups. You could actually have the name of them show up for each one. An example in game of this is right here. So we have our speed right there. And this one will actually follow the character, making sure that it's showing up what its title is. And just to see our speed in action, we can see my character moving like this. As soon as I hit the speed pickup, I get a massive boost in speed. And got to double jump over this. We'll explain why that is in a second. And it becomes really useful for seeing all the ammo and stuff like that, with what those pickups are essentially. There is a couple of things to watch out for when you do first set this up. Make sure that you do have a pickup right in front of you, because if the text does go off screen, you will run into a couple of issues when it's trying to set its position. So that's just a couple of things to watch out for while you are walking through that. Oh, the other thing I do want to mention, make sure you are not just copying what they're showing in the pictures. Make sure you are reading through, especially when it's talking about what settings for variables they use so that things can be exposed on spawn, stuff like that. Moving back to our rubric. That's our pop-up widget. And this very last one is moving away from the actual programming aspects. And this one's asking you to create an area layout. And the area layout must force the player to use different actions such as jump or double jump in order to shoot all the targets that you've placed around the level. So the goal of this game will eventually be just to destroy the targets. So we're going to be trying to create a level in mind that forces them to use the jump, double jump, in order to actually destroy all the targets. One other part of this level requirement, the targets should be different number of hits to destroy. So I did show that in the previous lecture, but I'll go over it again. So we've set up our targets, and they're just using a killable. We can access and change what values per instance right here in the level. So let's say we want this one to be 3 hits. And since we did change its number of health, I'd probably want to make it look a little bit different in game. Let's actually scale this up to be 1.5. Well, 1.5 is not very much, but well, let's go ahead with 3 since we're saying this one's going to take 3. So making it look visually different so that in game I can tell this one's going to take more hits to destroy than just this tiny little one we have. So I didn't change any code, but it is changing the values of these variables per instance. Now currently my level layout, if I actually play this, it's going to take 3 hits. Destroyed that one, and then I destroyed that one. I didn't have to use jump. I didn't even have to move from my starting position. So this would actually get a failure for that level layout. We took a look at how to create some basic shapes using the box brushes and stuff. This one is basically asking you to block out a simple level that forces the character to use those jumps. It should not just be an obstacle course that you set up where, for example, if this is up at the top of that, if I can still hit it from the ground and not use that obstacle course, or even if there were platforms over there, but if I can run around on the ground and destroy everything, that's not forcing the character to do it. So you may want to think about walls, some floors, ceilings, to kind of separate the areas out and actually create a true level itself that causes, that prevents the player from just quickly destroying and completing the level without using all of the features that we've added. So, are there any questions about any of the lab tasks or anything like that?
I don't have anything.
Okay. I'm gonna go. Sorry, what was that?
I said at least not at the moment.
Not at the moment. Okay, then I'm gonna go ahead and stop